Okay. In this video, we are in the phylum Cnidaria. And cnidarians are animals that are things like jellyfish and sea anemones and corals and a few other things that are out there. And their body plan is radially symmetric. But we're going to draw kind of the generalized body plan for cnidarians. They come in two forms. One form is called a polyp, which is a sessile form, or it's attached to a substrate like the ocean floor, because these are all, for the most part, marine creatures. And then we've got a medusa form, which moves around. It's modal. Okay, so sessile and modal. Sessile sits still, modal moves around. All right, so for the polyp form, I'm going to draw, this is going to be a longitudinal section. That's this. It's more or less symmetrical. It's the way it's supposed to look. So imagine we're looking down at a sea anemone from the side, and it's been sliced in two. So this is the polyp form in a longitudinal section. LS is what that is. So off the bat, we've got here some tentacles. There's a tentacle there. There's another tentacle over here. And then we have the body of the animal is surrounding a single cavity, single space in here. All right, so I'm going to be trying to make an outline of this body cavity. And I'll show you why we're doing this in a minute. I'm also going to add a little bit of color. Basically, I'm just following the lines that I laid down at first. Just making myself a little bit of a boundary for when I'm going to color this in here in a minute. And the tentacles can be very long. Okay, so what we've got here is we've got the animal has one body cavity right here, which is called the gastrovascular cavity, or from here on out, most of the time I'm going to refer to it as the GVC. Okay, and this is basically functions. Gastro is like the stomach. And then also this orifice serves to kind of circulate things around as well. And the GVC is lined with this stuff, which is called gastrodermis. And I'm going to color this gastrodermis in yellow, just so we know where it is. And gastrodermis essentially means stomach skin. And it is derived from the endoderm. Remember, cnidarians are diploblastic, so as they develop from a zygote into an adult animal, they only have two germ layers. And one of those germ layers is the endoderm, and the other germ layer is the ectoderm, but that's only in the immature form, in the embryonic form. As it grows into an adult animal, we don't call it the endoderm, we call it the gastrodermis. Okay, and this outer layer on the outside of the animal, we're going to call it something that you might be familiar with this word, epidermis. Okay, so the tentacles are aligned with this epidermis, using the second color, in this case blue. But notice I'm leaving a little gap in here because there's this space in between. That space isn't empty, we're just going to label it later on. Okay, so we're going to go down and around. So leading up to this mouth. And doing a pretty solid job of color in here. Solid B plus job of coloring in this epidermis. Trying to stay between the lines, which is why I drew them like that. So I didn't have to just eyeball it with the thickness of the lines. Okay. That'll work. This is not an art class. So okay, so now we've got the epidermis and we've got the gastrodermis. What is all this stuff that is in between the epidermis and the gastrodermis? That is a layer of a jelly-like substance called mesoglia. So we've seen mesoderm in triploblastic animals. We've seen mesohyl in the sponges, and now we're seeing mesoglia. And in all of these cases, we're seeing that meso word root, which just means middle. So it's the stuff that's in between the outer and the inner part, okay? All right, so we've got here, we've got an entrance into the GVC, and this is the mouth. But you'll notice that this cavity here doesn't go anywhere. There's the mouth, but it's a cul-de-sac. So it turns out that food goes in, it gets digested, and anything that is waste goes right back out the same way it went in. So this mouth, this orifice, also serves as the anus. This is one of the effects of being a diploblastic animal, having only those two germ layers, is you don't have a complete gut. The archenteron just ends up forming this GVC, which is lined with gastrodermis, and it's one-way in or out. It's not a one-way street, so you don't have like a mouth and then an anus at the other end. Okay. So between the tentacles and the mouth/anus, we have this region that's called the hypostome, which literally means it's under the mouth. And if you were to look at a sea anemone, you might see the tentacles, you may be able to see in the mouth, and you'd see that there's just kind of this area surrounding that. That's not outside here, but it's kind of surrounding the mouth, and that area is called the hypostome. Okay, one more thing that we're only going to have in our polyp form is this bottom part here, which anchors it to its substrate so it doesn't move around, except in some extreme circumstances. And I know you've seen this word before, but marine biologists I've spoken with call this a pedal disc. Not a pedal disc, but a pedal disc. So pedal, like the pedals on your bicycle, that's where you put your feet. And you might know that ped or ped or pod, all of those Greek word roots refer to the feet. So this thing functions like a foot to anchor the polyp to the ground, or whatever it's attached to. Okay, so notice how I drew these things here and I drew these things over here. These things are pretty much unique to polyp forms, and these things we're going to find also in our medusa form. So now I'm going to draw that. So a medusa form is in many ways like an upside down version of a polyp form. And another way of thinking about a medusa form is it's like your typical jellyfish. And that's what we're drawing here. I'm not giving myself much room here to double up these lines because I'm going to do just what I did over here on our medusa form. Okay. So now I'm going to double up these lines again carefully so I can use my blue colored pencil. Oh, careful, 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 careful. Okay, that's going to be where our epidermis stops and our gastrodermis begins, around that thing that's dangling down in the middle. Oh me, there we go, okay. All right, and now for the gastrodermis. Ooh. Managing not to cross the lines. All right. Okay, so now, once again, we've got gastrodermis, which is going to be lining our gastrovascular cavity, our GVC. Go ahead and color that in, same color. You don't have to use blue and yellow. You can use whatever two colors you have available, or whatever your particular preference for those colors, but I'm using these. So I've got, remember the yellow is gastrodermis, the blue is epidermis. So I'm going to color in this bit down here, going into the tentacles. Because it's a very similar thing that's going on where we've got an outer layer that is surrounding mesoglea, and the mesoglea in turn leads to the gastrodermis and the GVC. Okay, pretty good. All right, so again, we've got the yellow to indicate that that is gastrodermis. We've got the blue to indicate that that is epidermis. It's kind of hard to draw an arrow from over there all the way over here, so I'll just go ahead and label this again. We've got a tentacle over here, but rather than having a hypostome, we've got this bit that's kind of dangling down from the GVC. And this part over here, this hanging down bit, is called the manubrium. And at the end of the manubrium, we've got our mouth, which also serves as our anus because, you know, it's the same. These animals are all related. Some cnidarians only have a medusa form. Some cnidarians have only a polyp form. Some have both. But in those medusa forms, they have this bit that's the manubrium. It's analogous to the hypostome that allows the animal to eat. And, oh, can't forget the mesoglea. So the mesoglea is the jelly-like substance that is in jellyfish, and it is substantial. It's got some proteins in it, some collagen and some other stuff that kind of gives the animal a little bit of stiffness. But for the most part, the majority of it is water. And you've probably heard that jellyfish are like 99% water. And a lot of that is locked up in the mesoglea. Okay. So one more thing I want to add on here, and I think I'm going to need a new page, which is okay. I got pages to use. And that is a feature of the Cnidaria. So again, we're in the phylum Cnidaria, and that is the cnidocytes, or the stinging cells. So the tentacles are typically lined with cnidocytes. This is true for both the polyp and the medusa form. And the cnidocytes sting, and sometimes they have venom. They usually have venom, but the strength of that venom varies quite a bit. There are some jellyfish that can sting you, and you might feel like a bee sting, or you might not notice at all. Others have a sting that is very, very painful and can potentially be lethal if you get stung in the wrong place, or at the wrong time, or in the improper amount. So it can definitely make you feel not good, or possibly do some real harm to you. Okay, so for our cnidocyte, again, this is a small cell relative to the body of the animal. These are individual cells. So within a cnidocyte, we've got a cell that has a nucleus. There's also a covering to the cnidocyte before it is fired. And that covering has a name that we've seen before because it's lid-like. We saw a lid-like structure in the mosses too. And we're going to use that Latin word that means lid, which is operculum. Just to make a little note that an operculum is a lid. This little structure here is called a cnidocyl. And the cnidocyl is the trigger which causes this this cnidocyte to actually fire and do the action of stinging. So this is kind of like the ready to sting cnidocyte. Within the cnidocyte, we have this structure called a nematocyst. And nemato means thread-like. And cyst means bladder. So within this structure here, there's a reservoir of venom. And then once that cnidocyl is triggered, well, we still got our nucleus, we've got our cnidocyl. What happens is this nematocyst everts. So when this cnidocyte or this stinging cell is triggered, it's going to turn inside out. And this part of the nematocyst is barbed. It basically gets turned inside out, which is a fancy way to say that. It's everted nematocyst. So those barbs stick into the prey or the predator, as the case may be, whatever is getting stung. And this thread turns inside out and it shoots out that venom. So the venom is going to go whoop. It's going to kind of gleek out up here. So the whole thing kind of turns inside out, and that's how the venom is delivered, through this long thread-like structure. Okay, so these cnidocytes, which are stinging cells, are a shared derived characteristic that we find only in cnidarians. So jellyfish have them, sea anemones have them, corals have them, but again, your results may vary as far as what happens if you impact the cnidocyte and cause it to sting. All right, so that's all I got to tell you about cnidarians for now in this drawing.